Welcome back to Smarter Everyday Over Learning. Dear students, in this session, I'd like to share with you how to predict the shape and the geometry of the molecule. Okay, students, up to now, what are the topics completed? Everything I'll provide for you in the description. You can go through them. In our previous session, in our last class, just I explained to you about how to write the resonance structures and what is the trick to find the bond order. Okay, trick to find the bond order basing upon the total number of electrons and what is the bond order. Here is the simple trick. This class, the details I'll provide for you in the description once you can check it. Now students, in this session about some molecules and some ions, also how to predict the particular shape of a molecule. Let's see now. For example, if you take the example of carbon dioxide CO2 molecule, the shape of the molecule is linear. Okay, for CO2 the shape is linear shape, and for BF3 boron trifluoride BF3 molecule, the exact shape of BF3 molecule is planar triangular. Okay, for BF3 planar triangular. For silicon tetrafluoride SiF4, for this the shape is tetrahedral shape. And the last example is PCl5 phosphorus pentachloride, the main structure, the shape of this molecule is trigonal bipyramidal. Okay, these are the examples. Now students, how we can say, just how can we say the exact shape and particular geometry of the molecule? There is a simple trick for you. I'm going to explain in this session. Trick to predict the geometry. What is the main trick to predict geometry? This is for predicting the main structure. Okay, here is the tabular form. You need to identify, for suppose n value and structure. How can we find out the n value also? I'll be discussing with you now in this session. And for suppose n value is 2, the structure is linear structure. For suppose n value is 3, that is trigonal planar. If it is 4, tetrahedral. If it is 5, trigonal bipyramidal. If it is 6, octahedral or square pyramidal. If it is 7, the n value is 7, pentagonal bipyramidal. Okay students, this is about just to predict the structure. You need to remember this tabular form. This is the first step you have to remember. Now students, in this trick to predict the geometry of the molecule, you need to have two tabular forms here. This is the first one. We need to apply those two steps. This is the first table. Now for step 2, what we have to do for step 2, for predicting the shape. Remember, now we need to take out the lone pair of electrons. So if you want to remember this table, you need to identify the lone pair of electrons also. Here is the n value. In our previous table, basing upon the n value, what is the shape we decided. Now students, basing upon this n value and also basing upon the number of lone pairs, you need to identify and you need to predict the particular shape of the molecule. Here you can see, if n value is 2, the lone pair of electrons are 0, that is linear shape. If n value is 3, if the lone pair of electrons are 0 or 1, those are the shapes will be trigonal planar and bent shape. Like that, these are all the values and the shape. You need to remember these two tables. Okay, now let's see one by one all the examples. First of all, if you want to write this table, what are the rules you have to follow? I'll tell you. Already I have shown you the second table, students. While writing the second table, what are the rules you have to follow? That is for step 2. First of all, find the central atom and count the valency electrons. Okay, for suppose if any molecule, I'm going to write here, for suppose CH4 is the molecule. To this molecule you need to identify the shape of this molecule. Then students, what is the first step? Here I have written, you need to identify, find the central atom and count the valency electrons. So here is the central atom. In this molecule, the central atom is carbon. So basing upon the molar chart and basing upon the atomic number of carbon, you need to write the electronic configuration of 1s2, 2s2, 2p2. So you need to write the electronic configuration for this, and after that you need to identify the valency electrons. So here 4 valency electrons. That is the first step. When you have to write the second tabular form, you need to follow these rules. Now students, what is the second rule you have here? And add to this number all the atoms which form single bond and which do not add atoms which form more than single bond. Okay, here for suppose CH4 means C and all the single bonds only. C is the central atom and H hydrogens are the surrounded atoms here. So you need to add to this number all the single bonds. Okay, for suppose that is if any surrounded atoms, that means monovalent atoms are presented. That is about second point. And what is the third point? Here I have written add 1. That means add only 1. Each negative charge is presented. For suppose if there is a negative charge, that means that is a cation. You need to add 1 to this number. And if it is an anion, if it is a positive charge means that is a cation. Okay, cation. For this cation you need to subtract -1. Okay, add 1 for each negative charge. For each negative charge means for each cation, sorry, for each anion. Anion has negative charge. Okay, for each anion you need to add +1 and subtract 1 for each positive charge. If there is a positive charge, that means if there is a cation, you need to subtract 1. That is the third step. Now what is the fourth step here? Divide this number by 2. Why? Because each pair has 2 electrons. Pair means 2 only, no, right? Then students, you divide this number, what you have got that number, to that number you can divide with 2. And the final number you get is your n value. So students, up to now we have discussed how we got the n value. This is the complete procedure. Okay, use this number to compare with the table. I have written already 2 tabular forms. Okay, those 2 tabular forms you have to compare what is the n value. By doing all these steps you will get finally the n value. That n value you have to use this n value to the comparison with that tabular forms. Let's see one by one all the examples, students, by using all these rules and by using those tabular forms. Then only you will get clear cut conclusion about this. Okay, let's get into the class now. This is a introduction part only. Just what about here the examples I'm going to write, and here is the tabular form. Okay, right, and right, here is the example. First example, what I'm going to take. Here is the first example. Ion only I have taken here, PCl4+. Okay, in this ion you need to identify first of all what is the central atom. Okay students, that is about first point, central atom Ca. You need to identify. Here is phosphorus. Okay, basing upon this central atom, so phosphorus atomic number is phosphorus 15. You need to write the electronic configuration for this: 1s2, 2s2, 2p6, 3s2, 3p3. If you count all these electrons, you should get 15. So 15 electrons. It is okay. Now K shell, L shell, M shell. K, L, M. Here are the 2 electrons. Here are the 8 electrons. Here 5 electrons. So students, this is the outermost shell. Now the valency electrons are how many, students? 5 electrons. So this is the first point. You need to identify the central atom. In the second point, you need to write the valency electrons of the central atom. So here 5 electrons. Now what is the third step? Number of other atoms you need to identify. Other atoms. So here the other atoms are chlorine atoms. How many? 4 are presented. So 4 you need to write. Next one, you need to identify the charge of the molecule. Or Here is the charge +1. +1 means it is nothing but a cation. Right. Again, you have to see the rules. If it is a cation, if it is a negative charge, means anion. If it is a positive charge, you need to subtract 1 from that. So for this you need to subtract 1. So you keep it in your mind, this point. And what about fifth point? What you have to do, using the above rules, by using these rules you need to predict the n value first of all. Using these rules, students, here n is equal to valency electrons plus other atoms, then here is the charge you need to find out. So here one positive charge, you need to subtract 1 from that. Now how many valency electrons? 5 electrons, plus other atoms are 4 minus 1. Here the number what you should get here, 5 plus 4 9, 9 minus 1 8. 8 is the number. So according to rule, here is the rule 4, you can see, divide this number by 2. Okay, here we got number 8, you need to divide this 8 by 2. Then students, you should get 4, number 4. So this is the n value. Now also you can find out the number of lone pairs, number of LPs basing upon this n value. Okay, this n value minus number of other atoms. If you subtract these other atoms from the n value, you should get number of lone pairs value. Now n value means here what we should get? 8. Sorry, here 4, okay, not 8. 4 is the n value, minus number of other atoms here. How many other atoms? 4 only. Then 4 minus 4 is 0. Now students, let's see the second table. Here is the second tabular form. We got n value is 4 and lone pair electrons, LP, lone pair of electrons also 0 here, lone pair of electrons. So n value is 4 and lone pair LP is 0. Now students, the structure should be tetrahedral. Okay, basing upon this table, tetrahedral. So here you should write tetrahedral. Okay, this is the entire procedure how we can predict the PCl4 plus structure. Let's see example number 2. Second example, I have written here IF5. IF5, just molecular shape you need to identify. Here is the central atom. Is iodine. Okay, clear. Now you need to identify the valency electrons. Before going to do that, what is the atomic number of iodine? You have to know. Iodine is 53. Now you should write the electronic configuration as usual. So electronic configuration, it is the noble gas krypton, which has the atomic number 36, and from this 4d10, 5s2, 5p5. So this is the last shell, has 7 electrons. Those are the valency electrons. In this second step, the valency electrons are 7. Okay. Now students, you need to identify the number of other atoms. Other atoms nothing but the surrounded atoms. Here I is the central atom. Then fluorine is the surrounded atoms. Now other atoms are 5. So this is there is no ions. There is no ion, so you need to there is no need to write the charge of the ion. So you can ignore this simply. There is no charge. Right. Now n value you should find out basing upon these valency electrons plus the number of surrounded atom. 7 plus the other atoms 5 by 2. Okay, here is 12 by 2, that is 6. So students, here n value you got as 6. Now from this n value you need to identify the number of lone pairs. Lone pairs is equal to that n value minus other atoms. Other atoms means 5. Here is the n value 6 minus 5, that is 1. Okay, here lone pairs LP is equal to 1 and n is equal to 6. Now let's see this. While LP means lone pairs are only 1 and number of n value is 5 here. N value is 5. LP is equal to 1. Sorry students, here we have the n value not 5, here 6. Okay, so n value is 6. So you need to see here n value is 6 and LP 1, square pyramidal. Okay, the structure of this IF5 is square pyramidal. Right, this is the way how to find the structural geometry. Let's see the next example. SF6, next example. Okay, first of all, in the first step you need to identify the central atom is sulfur. Here atomic number is 16. Just to write the electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p4, K shell, L shell, M shell. Okay, this is the last, third shell means final shell, nothing but outermost shell, nothing but valency shell. So here 6 electrons, these are the valency electrons. Okay, and now valency electrons you got it, 6 electrons. Now you need to identify the other atoms, if there is a presence of other atoms or not. Other atoms is equal to how many here? 6 fluorine atoms are there. So there is no charge, so you simply ignore that about ions, there is no charge. Now students, how to find the n value means the number of valency electrons plus other atoms simply by 2. 12 by 2, 6. So n value is 6. Basing upon this n value, you need to identify the number of lone pair of electrons. Lone pair electrons is equal to n minus other atoms is equal to n is 6 here, other atoms also 6 here, so 0. LP is 0, n is equal to 6 here. N is equal to 6, LP lone pairs 0. Here you can see n is equal to 6, lone pair 0 means octahedral. Okay students, so here is the structure, octahedral. Right, now next example, CH3 minus. This CH3 minus, the name of this ion is carbanion. Okay, in this carbanion also you need to identify first of all the central atom. You know very well, central atom is carbon here. To this carbon, atomic number 6 and electronic configuration is 1s2, 2s2, 2p2. Okay, these 4 electrons are the valency electrons. Why? Because it is the valency shell, nothing but outermost shell. Here valency electrons is equal to 4. Now you need to identify the other atoms, how many are presented, how many are surrounded the central atom. Here 3 hydrogen atoms. Coming to charge, here is a charge. The presence of charge takes place only minus, that is an anion. So you need to add plus 1. So charge is here minus. To this you need to add 1. Now n value 4 valency electrons plus the number of other atoms 4 plus 3 plus 1. 1 means basing upon the charge there is an anion, so you need to add plus 1 to this. Now 4 plus 3 plus 1 by 2. 8 by 2, finally 4 we have got as answer. Now basing upon this n value, you need to identify the lone pair of electrons here. 4 minus 3. Okay, this 4 is the valency electrons and minus 3 is the other atoms. Here only 1 we got it. So n value is 4, Lp is 1. N is equal to 4, Lp is equal to 1. Let's see now here. N is equal to 4, Lp is only 1. The structure is trigonal pyramidal. Okay, right. The structure is trigonal pyramidal. Now students, this is about carbanion example. Now very familiar example I am going to write here. H2O. The shape you know very well. Reverse V, bent shape like this. Now what is the shape? Bent shape. Whether we get that or not, just let's see by doing this simple calculation. Here is the central atom is oxygen. Okay, oxygen, atomic number 8. 1s2, 2s2, 2p4 is its electronic configuration. Now students, if you segregate into shells wise, K, L. L is the second shell only is the last shell, nothing but outermost shell, valency shell. Okay, it has only 6 electrons. Now the valency electrons is equal to 6. Now you need to identify the other atoms if there is any presence of other atoms. Here hydrogen is presented, so 2. Coming to charge, there is no ion, so charge is 0. We can ignore this. Now calculation of n value. N is equal to 6 plus 6 means valency electrons plus other atoms 2 by 2. 6 plus 2, 8 by 2 is equal to 4. Now students, n value 4. Now basing upon this, first Lp, lone pair of electrons, is equal to that number 4. 4 means this n value minus atoms, other atoms means 2. 4 minus 2, so we have 2 here. Now students, n is equal to 4, Lp is equal to 2. N is equal to 4, lone pairs is equal to 2. Let's see now. N value is 4, lone pairs 2 means that is bent shape. So we got here the correct answer, bent shape. Okay, right. This is about the complete information how to predict the shape and geometry. I hope you have understood this class. Okay students, this is about how to predict the shape and geometry of the molecule or ion. This is the complete information basing upon the n value and number of lone pairs also. These are the shapes. So if you understand this class, if you like this class, please share to your friends and subscribe to this channel for my further updates. Thank you so much. Keep watching. Have a nice day.